Good morning, children. Today we'll start linear equation in two variable. So before going to start linear equation in two variable, I will say you about the general form of a linear equation in one variable and then general form of a linear equation in two variable. Just to see ax plus b. This is the general form of a linear polynomial because its degree is 1. Okay, so if you will equate with the 0, then it will be linear equation in a one variable, and its a solution. If you will find its a solution, so we have to imply, so ax will be equal to minus b, then imply that x will be equal to minus b by a. This is the solution of linear equation in one variable. So if you will represent it in a graph, so that is in a number line, yes, like this. This is x dash. This is the line for x axis. We are going to find x. One example we will take. 2x minus 4 equal to 0 implies that 2x will be equal to minus 4 by 2, that is 2x equal to minus 4 implies that x will be equal to minus 4 by 2, that is will be equal to minus 2. So where it will be represented, this is the number line. You will take this one is 0, here 1, this is 2, this is 3, this is 4, this is 5. Like this it will be going on. Same with this side, this is minus 1, this is minus 2, this is minus 3, minus 4, 5, like that, so on. Okay, so what is x? X equal to minus 2. So minus 1, minus 2, this one. Here this is the representation of the root of linear equation in one variable. This is the representation of root of linear equation in one variable. This is, you can show it in a graph also, say graph x axis only, because this is the linear equation in a one variable. Now start linear equation in a two variable. So linear equation in two variable, see, we have to take two variables like x and y. So ax plus by plus c equal to 0 is the linear equation in two variable. This is the x and y, and this is linear because where degree is 1, here degree is 1. Okay, one example also we can take. 2x plus 3y minus 5 equal to 0. This is the one example of a linear equation in two variable. Okay, so here how can we find its zeros? Its zeros can be found by finding y. So sometimes some people they are finding x, and here y. Sometimes some people they are finding y. But here, if you will find y or if you will find x, one will be dependent variable, another one will be independent variable. Generally, we should take y, we have to find y. So, y will be dependent upon x. So, x will be independent and y will be dependent. How one independent and dependent? See. So, this example I will take. 2x plus 3y minus 5 equal to 0 implies that 3y will be equal to this minus 5, it will go that side, according to transpose it will be 5, and 2x will go that side, it will be minus 2x. Implies that y will be equal to 5 minus 2x divided by 3 transpose, it is multiplied, here it will be divided. Here we will find the value of x and y because they are variable, they are unknown. If we put the value of x, I will put the value of x is 0. So I will make a table that is called the solution table. Here x, this one is y. We had known in coordinate geometry, whenever I was showing you value of x and y, the point represented in coordinate plane is represented by x, y. X is axis and y is ordinate. The same way, whenever we will show it in a coordinate plane, in a graph, we have to find x and y. That one we will show in a graph as usual in a coordinate plane. So just this is x, y. So if we put the value of x is equal to 0, 2 into 0 equal to 0, 5 minus 0 equal to 5 divided by 3. This is 5 divided by 3. If we will take the value of x is 1, 2 into 1 equal to 2, 5 minus 2 equal to 3, 3 divided by 3 equal to 1. So 1, 1. So here, if you are in confused, I am finding y equal to 5 minus 2 into 1 divided by 3. This is equal to 5 minus 2 1s are 2 divided by 3. 5 minus 2 equal to 3, 3 by 3. Okay, 3 by 3 equal to 1. So it is taken 1. So this is 1, 1. This is 0, 5 by 3. Okay. If you will take minus 2, x equal to minus 2 I have taken. If you will take x equal to minus 2, the value of y will be equal to here 2 into minus 2, minus into minus equal to plus, this is a plus, 2 to the 4, 5 plus 4 equal to 9, 9 divided by 3 equal to 3. So this is a minus 2, this is 3. And this one minus 2, 3. Okay, so this way, these are the solutions of this linear equation in two variable. Here I took the example. This is the general form of a linear equation in two variable. Here you can understand, you can find, and you can observe any value of x you will take, because I have taken 0 and I got y equal to 5 by 3. I have taken 1, x equal to 1 and I got the value of y equal to 1. I have taken minus 2 for the value of x and I got 3 is the value of y. So for any value of x we can get the value of y. So like that, any value will take, any value of y we can get. So this is the solution, this is the solution, this is the solution. Like that way, how many solutions we can get? It is infinite number of solutions. Many solutions we can get. So for a linear equation in one variable, we are getting one solution. Linear equation in one variable, x plus b equal to 0, imply that x equal to minus b, implies that x equal to minus b by a. This one was the solution. This is the only one solution in linear equation in one variable. But in a linear equation in two variable, we are getting number of solutions. For any value of x, we will get the value of y. So that x, y is the solution of linear equation in two variable. Okay. So here we have to understand what. Here you will put the value of x, you will get the value of y. So y is dependent upon x. X is the independent variable, x is y is dependent. So y value will be found by taking the value of x. Okay, so this is dependent, this is dependent, this is independent. Okay, so still the both are variables. If you will put the value of x, you can get the value of y. Sometimes some people they are taking x like this here. 2x equal to 5 minus 3y. 5 went that side, 3y also went that side, implies that x equal to 5 minus 3y by 2. Here they are taking. So what will be the difficulty here? Whenever you will find the solution table, this is x, this is y, this is x, y. Generally we have to write first x, but you have to write the value of y here first. For example, I will write the value of y equal to 1, then 3 ones are 3, 5 minus 3 equal to 2, 2 by 2 equal to 1. Then in value of x you will 1. Will write 1. But the confusion is that the people what the wrong they will do. So they will take the value of y, but they will write it in x. Actually, they will take the value of y first, because if you will take y is independent, the value of y will be taken and can find the value of x. But by taking the value of y, they will write in x first. Then they will put the value of x in y. So that is the confusion will happen. So better always you should take y. Otherwise, according to your convenient, so which one will be suitable for you to find the value of, find the solution x, y, you can take. Now this is the solution we found. So this is algebraic. If you will find graphically, so what will be? So we have to show this. I have showed you graphically the linear equation in one variable. Now I will show graphically the linear equation in two variables. This one I will show in a graph. How will you do? Just I am writing the solution here. So the equation is 2x plus 3y minus 5 equal to 0. The solutions are zero, 5 by 3, 0, 5 by 3, so 1, 1, 1, 1, minus 2, 3, minus 2, 3. Okay. Now, how will you show it in a graph? So, you will draw this line. You have known this is the coordinate plane. In a coordinate unit, I have taught you x dash, arrow mark will give x dash you will write. Here arrow mark will give y dash you will write. After writing this, here this is 1, 2, 3, 4, 5, 6, 7, 8, 9 like this. This is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Here 1, 2, 3, 4, 5, 6, 7. This side minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Like this. What we will do here? Here in a graph paper, you have this line. Here in between these 2 points, 10 small divisions are there. Very small, 10 small divisions are there. So that 10 small divisions, sometimes it may be 1 centimeter. So it is taken 1 unit. So that one you have to write it in scale. Here you have to write the scale. In both axes, each 10 small division equal to 1 unit. In both axes, each 10 small division equal to 1 unit. Sometimes it may be 1 centimeter or less than 1 centimeter or more than 1 centimeter. That's why we have to take each small division equal to 1 unit. Okay. Now we have to show x dash over, y dash over, and scale we have written. You have to follow this. Then solution 0, 5 by 3. Let it be 5 by 3 equal to 5 by 3 equal to 3 ones are 3 on 2 by 3. Okay, 1 is completed, and out of 3 equal parts, 2 equal parts you take. So first in x-axis is 0, in x-axis is 0. In y-axis 1 whole 2 by 3, 1 whole it is, and 2 by 3. It will be divided into 3 equal parts. This is 10 small division will be divided into 3 equal parts, and 2 equal parts will take, because 2 by 3. So this one. This is 1 whole 2 by 3, and this x equal to 0, y equal to this one. So this one is the point. Okay, and you have to write here 0, 5 by 3. Okay, the point should be located. Okay, next 1 1 in x axis 1, y axis 1. This one is the point. X axis 1, y axis 1. This is 1 1. Next third one, minus 2 3. This is minus 2 3, x axis minus 2, y axis 1 2 3 here. This one is it, minus 2 3. You have to show. Next we got the 3 solutions. Next we have to join the lines. This one will be a, you see, this one will be a straight line, and here in the straight line you have to write the equation, that is 2x plus 3y minus 5 equal to 0. This is the equation you have to write. You have to locate the point. Okay, and you have to write minus 2 3 0 5 by 3 1 1 like that, and you have to draw the line, and above the line you have to, or below the line you have to write the equation, that is 2x plus 5y minus 5 equal to 0. And here each and every point on this line are one solution of the equation. Each and every point on this line is a solution of this equation. So linear equation in two variable has one solution or a zero solution or many solution. Obviously infinitely solution or many solution. Very good, Ashok Patra, very good, nice. That is infinite number of solutions. Okay, so here each and every point, because a line consists of infinite number of points, and as each and every point is a solution of this line, so infinite number of solutions are there. One thing you got, linear equation in one variable has only one solution. Linear equation in two variable has infinite number of solution. Here we got this. And how can we represent in a graph? That part also you understood. And how to find the solution also I have told you. Again here 2x plus 3y minus 5 equal to 0. For any value of x we are getting the value of y, and that one we are finding like we took here 3y equal to 5 minus 2x, implies that y equal to 5 minus 2x by 3. If x equal to 1 we are taking, implies that y equal to 5 minus 2 into 1 by 3, that is equal to 5 minus 2 by 3, that is 3 by 3 equal to 1. When x equal to 1, y equal to 1, and we showed here. This is the way we have to show linear equation in one variable and a linear equation in two variable, and I think everybody you can find the solution by taking the value of x and the value of y you can get, and x y is the solution of a linear equation in two variable. Okay, this is the way you will find. Now we have to represent this in any day-to-day life. Any what problem is there, so that how can we represent any linear equation in two variable. One question is there, let the cost of a notebook is twice the cost of a pen. So how can we represent it in a linear equation in two variable? Okay, I can draw this. Yes. So it is asked, it is told that the cost of a notebook is twice the cost of a pen. Cost of a notebook is twice the cost of a pen. How can we represent it in a linear equation in two variables? So which will take let the cost of a notebook is given, it's twice the cost of a pen, so you will take the cost of a pen is X rupees. So cost of pen is X rupees and cost of notebook is Y rupees. Because two unknown things are there. One is notebook, another one is pen. So and there is a relationship between notebook and pen, and the cost of notebook is twice the cost of pen. So let first take the cost of a pen is X rupees, cost of notebook is Y rupees, and we have to relate. So according to question, the cost of notebook Y, this Y is equal to twice the cost of a pen. Cost of a pen is X, implies that Y will go that side, 2X minus Y will be equal to 0. Here we have AX plus BY plus C equal to 0, but here A is 2, B is minus 1 and C is 0. So this is in the form of a linear equation in two variable. A 2x minus y equal to 0. Am I clear? And any problem is there, you can find the solution also. In that way, you can find the value of x, value of y, and you can show any situation in linear equation in two variable if two unknown things are given. So that two unknown things will be two variables, and what is the relation is given. According to that relation, you will make it a linear equation. Okay, I think everybody understood, and how to show it in a graph also everyone understood. Now I will show you how another one thing I will show you. So linear equation in two variable and two equations, that is in a 10th standard. This is in 9th standard, so just little bit extra I will say. For a 10th standard, linear equation in two variable and two linear equation in two variable means pair of a linear equation in two variable. Pair of linear equation in two variable. So AX plus BY plus C equal to 0. This is one equation. Another equation, AX plus BY plus C equal to 0. So here, as both are the same, so what we will do? You will take this is A1, the coefficient of X in the first equation A1, in the second equation coefficient Y is B1, constant of is C1. But in second equation, we will make it A2, this is B2, this is C2. And here, they may have, just extra thing I am saying, they may have unique solution or many solution or no solution. They may have unique solution or may have many solution or may have no solution. So according to coefficient, I am just saying it is not required, just extra things I am saying, just keep in mind it will be required in the 10th standard. So if unique solution here, according to algebraic condition, A1 by A2 will not be equal to B1 by B2, and if you show it in a graph, so the graph will intersect at one point. Both graphs will intersect at one point. So this one will be a graph and this one will be a graph. Both graph will be drawn in one graph paper, and we will see that both graph will intersect at one point. And during that time we can see A1 by A2 will not be equal to B1 by B2. So that is a unique solution. But if they will overlap, the graph will overlap. Equation 1 and equation 2 both will overlap. Like this here graph, here is a graph, here another one graph. They will overlap. In that case, what happened? A1 by A2 equal to B1 by B2 equal to C1 by C2. It will happen. So in that case, there will be many solutions because common, each and every point is common. So many solutions are there. So that is called a linear equation in two variable, and also they have many solutions and they will be overlapping with each other graphs, and coefficient relation A1 by A2 equal to B1 by B2 equal to C1 by C2. But whenever the graphs will be parallel, there will be no intersection, there will be no common solution, so there is no solution. In that case, algebraic condition A1 by A2 equal to B1 by B2 is not equal to C1 by C2. It will happen. So I think everybody you understood. You will do exercise 4.1 and 4.2. Tomorrow I will teach you 4.3. Okay. Thank you.